Okay, so let's try to solve this problem, longest palindromic subsequence. The problem says given a string B, 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 A, B, okay, and we need to find the longest palindromic subsequence. Longest palindromic subsequence over here is B, 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 and if you skip A, and then we'll have B, B, B. So 4 times B. So 4 times B, and length is 4. So you need to return 4. Similarly, there are another example given CBB CBBD. Okay, and over here, what is the longest? This BB. Okay, so if you skip C and D, the subsequence becomes BB, and longest. So longest length is 2, and longest will be 2 only. Now over here, as the problem says that we need to find the longest or max of something or minimum of something, then which algorithm comes to our mind? So it is dynamic programming, right? So you can refer dynamic programming. Before jumping to that, let's try to understand like what is palindrome. So palindrome is basically if we cut in the middle. So if you cut in the middle, like say A B A, so both the sides are the mirror of each other. So let's take another example, A B B A. So if we cut in between, like both the sides are mirror of each other, right? So if we reverse the string also, so if you reverse the string, so if you reverse the string also, it will be same like AB. What will be the reverse of what will be the reverse? ABA will be the reverse. Similarly, this also AB BA. So this will also the reverse, right? So in the reverse also, both the strings are same. Okay. Now over here, like looking at the problem, like what generally comes to our mind, right? So what we can think of, like you can generate all the subsequence, right? So you can generate all the subsequence. So what will be the subsequence? So B will be A. So let's take this example. So B will be one subsequence. Another B will be another. If we take second character, so this B will be a subsequence. Another B will be a subsequence. A will be a subsequence. B will be a subsequence. Now B will be a subsequence. B will be a subsequence. B 4 times B will be a subsequence. So you have taken only the palindromic subsequences over here, and among this, if we try to find the largest, so then we'll find B 4 times B, or length will be 4 over here. Okay, I mean that's fine, but is there any intuitive approach to this? Let's find out. Okay, so let's take an example over here. Same example, B A B. Okay, now if you see, if we are moving towards each other, so if we start from beginning and start from end, if the first letter and the last letter are same, right? So then it can be part of the palindromic subsequence, right? We can think of like this will be a palindromic subsequence. Now after that, so this will add 2. So this will add 2 into the length, like into the palindromic subsequence length. Okay, and then we need to find the length between this particular substring, right? So over here, if we see like B, now we'll get BBA. Okay, now if we get BBA, now this part and this part, first and last letter are not same, right? So if the first letter and last letter are not same, then what we can think of? We can think of removing the first letter. So then what will get? BA will be a subsequence, and then if we remove the last letter, then BB will be a subsequence. Okay, and if we get the maximum between these two, so what will be the maximum? Maximum over here will be 2. So this will return 2, and 2 we already got 2. So 2 plus 2 will be 4. Okay. So now it basically it create two cases. So either so let's write over here. So either first letter and last letter of the string are same, and first and last letter of the string are not same. So basically when it was same, then what we did, so we had taken 2 plus and then we tried to find the longest subsequence for the rest of the string. So this is BA. Okay, and over here what we did, so we did maximum of when we did not find, so we had BBA, then when we did not find that when we did not find like BBA and B and A were not same, so then what we did maximum of BA and BB. So we removed the first letter from the first letter, we created a subsequence by removing the first letter, and we recreated a subsequence by removing the last letter. Now out of this, when we got when we'll get BB over here, so again we can find the longest palindromic subsequence. So then what we'll get, so we'll get 2, and 2 plus 2 will be 4. Okay, but we can see over here we are doing this part recursively, right? So when we solved, right, when we first initially checked like the first and last letter of same, then we are trying to find the longest in the substring. Similarly over here, when the first and last are not same, then we are trying to find the longest between the two strings, right? So I mean we can use recursion over here, right? We can use recursion and then try to find the longest. Okay, so let's check that. So let's say we can have a function Fij. Okay, so now over here, so F so basically what I'm trying to say is BB. Now we'll take 2 pointers over here, 2 index over here, so which starts from beginning and which starts from end. Okay, so now if let's try the case, let's try to write the cases over here. If a sub I is equal to a sub j, then what we did, we can return 2 plus f of I plus 1 j minus 1. Okay, so this is case 1. Okay, because we need to find the remaining part of the string, this BBA part. Okay, so this is done. Another case would be like when this first letter and last letter are not same, then what we did, we tried to find the max. So then what we need to do, return maximum of f of I plus 1 j comma f of I j minus 1. Okay, so this is case 1, this is case 2. Okay, and now if we write the base case, we are done, right? So now what will be the base case? So if I exceeds j, then return 0. Okay, and if it is single character, right? So if it is single character, so that will be a palindrome, right? So B is a palindrome, A is a palindrome. So in that case, if we say like if I is equal to j, so return 1. Okay, so this is done. Now what will be the time complexity? So time complexity would be 2 to the power n. Space complexity also O of n, because you are using a recursive call stack over here. So this is time complexity 2 to the power n, and space complexity to O of n. Okay, so over here, so this is, I mean, this solution will work, but it will get in TLE because it is the time complexity exponential over here, right? Okay, so if we try to draw the recursion tree, okay, so if we try to draw the recursion tree, then what we'll see, like we'll see overlapping subproblems, and whenever we are having overlapping subproblems, then there is a chance to optimize with dynamic programming as we have done before. Okay, so two approaches we can take. So again, like we can have top down and bottom up. So top down means larger to smaller, and bottom up means smaller to larger. Okay, so we'll first solve the larger problems and then we go to the smaller problems, and bottom up is smaller to larger. Okay, so top down is memoization with recursion, and bottom up is tabulation. Okay, so let's try to code this up. First we'll declare a variable to store the length of the string. Okay, then we'll define a function. This function will accept two parameters, I as index, j as index. Okay, and type would be, return type would be integer that you can mention. Okay, now over here we'll write the case, like base cases later, but first of all let's write the case 1 and case 2. So case 1 would be if s of I is equal to s of j, then what we did, we returned 2 plus, and you call the same function, okay, recursively for the remaining part of the string. So I plus 1, j minus 1. Okay, so case 1 is done. Then case 2. Case 2 is return maximum of LPS I plus 1. So remove the first letter from the string, I plus 1 j, comma LPS, remove the last letter from the string, so I j minus 1. Okay, so this is done. Now we'll write the base cases over here. So base case would be if I greater than j, if I exceeds j, then return 0. Okay, then another case would be like if I is equal to j, if it's a single character, then the palindrome length will be 1. Okay, so return 1. Okay, so base case is also done. Okay, now we'll call the function LPS of 0 n minus 1. Okay, sorry, return. Okay, so it's running fine. Okay, but if we execute this, it will obviously give us TLE. So let's try to optimize this using top-down dynamic programming. So as of now I will take a LRU cache over here, but we can declare DP table over to the DP table and do the same thing as we have done before. Okay, so top down dynamic programming. Okay, so you can import from functools import LRU cache. Okay, I'm doing this just to save the time because it's really easy. Okay, sorry, import spelling mistake is there. Okay, so now over here I will declare LRU cache max size is equal to none. Okay, so max size equal to none. Okay, max size S would be capital, I guess. No, add LRU cache max size. Max size is okay, so it will be lowercase. Awesome. Alright, it's running fine. So top down is done. What will be the time complexity for this? So time complexity would be O of n square. Okay, O of n square. Space complexity would be O of n square for the DP table or LRU cache, and then O of n for the auxiliary stack space. Okay, because we're still using recursion, so we'll have the auxiliary stack space and it will have maximum size. Worst case it will have maximum size of n. Okay, so this is done. Okay, so let's try to optimize this. So let's try to remove this auxiliary stack space over here. So then in that case we need to follow a bottom-up dynamic programming. So bottom-up dynamic programming. Okay, so we'll copy the same function over here. Okay, again we'll declare a variable to store the length. Okay, then what we'll do, we'll run a loop. Okay, so run a loop. So for this case, so you can say like for I in range n, first we'll declare DP table. So DP of, let's use the list comprehension over here. Well, D2D will declare DP2D table, and for in range n. Okay, so DP table has been declared. Okay, so 2D DP table is done. Okay, now we'll write the case for this one for a single character. So for I in range, DP of I would be 1. Okay, next we'll run another loop, 2 loops. Okay, so 2 indexes we have. So for I in range will run, so this I will start from right. Okay, so I in range reversed another loop would be for sorry, I am putting braces over here. I always do this while switching programming languages. Okay, for j in range, okay, for j in range it will start from I plus 1 till n. Okay, and now we'll write the case 1. So case 1 was if s of I is equal to s of j, s of j, then dp of ij is equal to 2 plus I plus 1 j minus 1. So 2 plus I dp of I plus 1 j minus 1. So dp of I is 2 plus dp of I plus 1 j minus 1. So this is done. Else dp of ij is equal to max of dp I plus 1 j dp I plus 1 j or dp I j minus 1, dp I plus 1 j, dp I j minus 1. Okay, so this is done. I plus 1 j, I j minus 1, then we'll return dp of 0 n minus 1. Okay, so let's try to run this. It's running fine. Let's try to submit this. Okay, it accepted as well. Okay, so what will be the time complexity? So time complexity would be O of n square. So we are running 2 loops, so there is no improvement, but space complexity would be O of n square, just O of n square, because we removed the auxiliary stack space. Okay, so this is done. All right. Okay, can you still optimize this? Okay, so I think we can space optimize this, because you can see over here, so you are referring only the second row, the previous row. So this is previous row, and another is the current row. So dp of I is the current row and dp of I plus is the previous row. Okay, so you are referring 2 rows over here. Okay, so in that case what we can do, so let's try to optimize this. Okay, we can optimize with 2 1D array, so rather than using 2D FDP array. So one will declare as previous, another will declare as current. Okay, so current will be 0 star n, and this is not required anymore. Okay, so this is done. Okay, so over here this part we can put over here, because there is no need to do over here. Okay, so we can remove from here, right? So dp of I would be current, so dp of I would be current, so dp of I would be current, and dp of I plus 1 would be previous. Okay, if you follow this, I think we'll be able to optimize this. Okay, so we'll remove this one, rather we'll place over here. Okay, so dp of I so this will be current. Okay, so this is done, we don't need this anymore. Okay, next dp of I, so this would be current, this would be previous. Okay, then this would be current, this would be previous. Okay, my bad, dp, this will be current, this would be previous. Okay, anyone else? Now we can return either previous or current, so dp of previous of n minus 1. Okay, but over here after this loop ends, so we need to switch current previous with current. So previous would be, can switch current. Okay, so I think we're good. Let's try to run this. Awesome, it's running fine as well. All right, so I mean, if you have still if you still I forgot to write the comment over here, so this is case 2. Okay, so now the time complexity would be O of n square, same, but space complexity would be O of n, because O of 2n or O of n. Okay, now that you have understood the previous approach over here, so let's try to find if there is any alternate approach. So let's check that example. B B A B, sorry, triple times B we had. Okay, B B A B, triple B A B. Okay, now over here what we had found, like the length was 4 because we had 4 times B, and that was the subsequence of length 4, longest palindromic subsequence. Okay, but when we try to get a palindrome, right, so basically it's a mirror of each other, right? So it's a mirror of each other. Okay, so can you not try like reversing the string and then find longest common subsequence over here rather than finding the longest palindromic subsequence? Okay, so let's check that. So over here, if you reverse this, okay, so what we'll get B A B B B. Okay, and over here what is common? So let's draw the lines. B is common, B is common, B is common, B is common, and these lines are not overlapping. Okay, so basically this is a common it's a common subsequence. Like this is a common subsequence, we got B B B. Okay, and this is the longest. Okay, so over here you can see that this is the longest and it is length of 4. So we can build an intuition over here, right? If you reverse the string, okay, and then if you find the LCS between the original string and the reverse string, then we can get the longest palindromic subsequence over here. Okay, so basically what I'm trying to say is like LPS is equal to LCS of the original string and we can reverse the original string. So if we try to get this, right, if you try to get LCS over, if you try to get the LCS, longest common subsequent, then we'll get the LPS over here. Okay, I mean we can follow the same code whatever we have done, okay, in the in our previous approach, like in the previous video, like LCS. So there is a video for this getting longest common subsequence, and then what you can simply do, you can reverse the string. Okay, reverse the string and get the LPS, longest palindromic subsequence. Okay.